All right, so today we're going to be talking about applications of systems, or how systems of equations can really help us in the real world. So our first problem that we're going to do today is that Ben tells his sister Katie that he is holding 20 coins. And as I go through this, I'm going to write down some important information, and I recommend that you underline it in your notes. So important info, Ben tells his sister Katie he is holding 20 coins, all of which are either dimes or quarters. So dimes and quarters. The total value is $4.10. So $4.10. And he tells his sister Katie that if she can guess how many of each coin, he'll give the money to her. So we have to solve this problem for Katie. So what are we really looking for here? Well, we're looking for the number of dimes that he's holding and the number of quarters that he's holding. So those two are going to be our variables. So I will write D is the number of dimes, and Q is the number of quarters. And now we can write a system of equations. So we have two types of information here. We have the number of coins, which is 20, and we also have the dollar amount, which is $4.10. So I'm probably going to have an equation for the number of coins and an equation for the money that it actually is. So I will create my system, and if I'm doing number of coins, the total number of dimes plus the total number of quarters has to equal 20. So D plus Q equals 20. Now, we know that dimes are worth 10 cents and quarters are worth 25, so every dime is worth 10. So 0.10 D plus 0.25 Q for 25 cents equals $4.10. All right, so now we can solve it. We have a couple different ways we can do it. We can either graph, or we can use substitution, or we can use elimination. I might use elimination because both of my equations are already in standard form. They're already lined up by D's, Q's, and my equal sign. But all I have to do is multiply by some factor to get something to cancel. So I might multiply this first equation by negative 0.1, because that way my dimes cancel. I could also multiply by negative 0.25, and my quarters would cancel. There are a few different ways we can do it. So I'm just going to multiply by negative 0.1. So this will be times negative 0.1. And I'll rewrite my system, I'll do it down here. So I'm going to have negative 0.1 D minus 0.1 Q equals negative 2. And my other equation is 0.1, I don't really have to put the 0 there, D plus 0.25 Q equals 410. And now when I add these up, my dimes are going to cancel. So add them together. I have 0D, negative 0.1 plus 0.25 is going to be plus 0.15 Q equals 410 plus negative 2 is going to be 210. So I really have 0.15 Q, this is just 0. 0.15 Q equals 210. So when I divide by 0.15, both sides, I find that Q equals 14. All right, so the number of quarters I have is 14. Now I can use this to plug into one of my other equations, doesn't matter which one, to tell me how many dimes. So I might plug it into this first one, because that way I don't have to multiply by anything. So every time I see a Q, I'm going to plug in 14. So D plus Q, so plus 14, equals 20. And when I subtract 14, I get that D equals 6. So the number of dimes Ben has is 6, and the number of quarters he has is 14. All right, so that's how we can solve one type of problem, but let's do another one. All right, so our second problem here is that the sum of two integers is 45. And as I go along, I'm going to underline some important info. So the sum of two integers is 45. The larger is 3 less than 3 times the smaller. Find the two integers. Okay, so what are we asked to find here? Well, we're asked to find the two numbers, and we know one is larger and one is smaller. So I'm just going to call these two L and S. So L is my larger number, and S is going to be my smaller number. Now I can set up a system of equations. So I'm going to have, I know the sum of the two integers is 45. So that means the larger plus the smaller equals 45. So L plus S equals 45. And I also know the larger is 3 less than 3 times the smaller. Okay, that's a lot of words. So the larger is, that tells me L equals, the larger number equals 3 less. So 3 less than something means we're going to have something minus 3. So 3 less than 3 times the smaller. So 3 times the smaller number is going to be 3s. So my equation is L equals 3s minus 3. Okay, so now I can solve my system of equations, and I have a choice here. I can either use graphing, or I can use substitution or elimination. Now, I might use substitution here because I see that I already have L equals something. So anytime I see an L in the other equation, I can just plug in this. So let's do that. Let's take the first equation. So I'm going to have L plus S equals 45. But every time I see an L, I'm going to plug this in. So 3s minus 3 plus s equals 45. Now I can combine like terms here. So I'm going to have 3s plus s. So 4s minus 3 equals 45. I can add 3 to both sides. And I get 4s equals 48. Divide by 4, and I see that s equals 12. So my smaller number is going to be 12. Now I can use this and plug it into one of my equations to solve for L. I might plug it into my second equation here, because this will tell me L equals right away. So I don't have to do any configuring from one side to another. So I'll bring this up here, and every time I see an S, I'm going to plug in 12. So L equals 3 times S, or 12, minus 3. So 3 times 12 we know is 36. So L equals 36 minus 3. So my larger number is going to be 33. And it's good to check yourself. The larger number is in fact larger than my smaller number. And when we add them up, we should get 45, and we do. And the larger is 3 less than 3 times the smaller. So if we multiply the smaller by 3, I get 36. The larger should be 3 less than 36, which is 33, which is awesome, which is what we got. All right, so I will leave you to try the problem at the bottom of your guided notes. Thanks for watching.